All right, can you all say this?
Yes.
Okay. All right. Good afternoon, everyone. This is a visual improvement to the pedagogy of introductory logic. So, very long name aside, let's talk about what that means. So, first off, why did we do this? Well, we've noticed that formal logic is a difficult subject for a lot of students across different majors, across math, across computer science, across, in particular, philosophy, because it introduces unfamiliar notation. The new symbols, they frighten a lot of people, and it just doesn't make sense. There's also a lot of proofs that you do, natural deduction, for instance, that's one of the big ones, and that just scares a lot of people off. So, one thing that we noticed, in addition, is that few tools actually give students what they need. There are online theorem provers and solvers all over the place. But in our opinion, they're very few and far between because when you go to them, you look at them, and even to us, people, students who have been doing this for a while, it can, it's daunting. So imagine how it is for someone who's actually trying to learn the subject for the first time. In addition, textbooks can give examples and problems, but practice makes perfect. And what we want is a way to combine all of the different notations across the different subjects, and more importantly, teach the underlying concepts like the rules and the axioms. So the main idea with this is that interaction is key. So being able to see and change what you're doing helps the students immensely. So what did we do? Well, we created a tool called LLAT, the Logic Learning Assistance Tool, and it teaches propositional and predicate logic, first order predicate logic. It's aimed for students in the Philosophy 310 course, which is the Introduction to Formal Logic course here at UNCG. But it also teaches a lot of the material that's in CSC 350 in chapters 6 and 7 of the Hein book. So students can construct and design truth tables, truth trees, look at different well-formed formulas, and there are several algorithms they can run. Um, so it's aimed at college students, but this can be adapted to, for high schoolers, for professors, for really anyone that wants to learn this stuff for the first time. And a cool feature is that you can export certain things in the program as a dot text file, a LaTeX file, and as a PDF. There are other formats that are planned in the future, but those two are the biggest ones that we thought we should implement. All right, so I'm going to pass it off to Chris to talk about the front end.
Okay. So for the front end, it was constructed using JavaFX, and we're following an MVC design. The main application is structured by a border pane, which is a predefined JavaFX layout that portions the screen into 5 sections, top, right, bottom, left, and center. So we constructed these sections individually and then joined them all together on the final view to get the final result. The application view serves to take in well-formed formulas, and then based on what algorithm is selected, we're either displaying a truth tree, parse tree, truth table, and sometimes a combination of those. Some of the helpful information that we're showing is that if you hover over a button, you'll get a tooltip that displays the name of that symbol. If you right-click one of the symbols, you'll get a box that is populated with names, formal names, rules, and examples for that symbol. And to move on to the connection between views and models, we have 2 avenues of communication. It's either through an event bus or through the controller. Mainly the views are communicating via the event bus. Each view gets a listener that can catch the event, and then either it stops there or it can continue on throwing events. For the communication between the views and the models, each view has access to the controller, and then the controller has as attributes the models as well as methods to perform some action on those models that the views can access. So next, we'll have Nadia explain the language translation.
So, hello, and as part of this team, I work on the language translation API. So, the basic idea was we wanted to give the user the ability to choose whatever language they wanted to use. That is to say, not only English speaker can use our app, which we think is a great feature. So the basic idea was to use the Google Cloud Translation API, but because they were using Java 8 and our project was based on Java 15, we were having a conflict. So that API was not working. Then we have to kind of mingle around and find something else, which we found Google Script, which is a great platform, and it has a translate API. So with this, we just created a translate script, which was used as a simple API call. And that was basically what we needed for our app. So it was simple and straightforward. So on the next slide, I just put like a screenshot of what it should be looking like. And this is what Chris was talking about. When you right click on the symbols on the right, you can see some of the description of this. This is in English, and I translated to into French to kind of just show how it would look like. And if there is any French speaker, you can feel free to just kind of confirm. And yeah, even though Joshua probably will be going over the actual demo, so you will be seeing that. And with that being said, I will pass it to H with the database subsystem.
Hello. All right. So I worked on the database subsystem. And so with the design of the database, it was designed with Amazon AWS database and MySQL. So the database was used primarily for user login credentials so they can register and log in into an account. And with that account, they can have a history of their input and also a preference of theme and their language selection from what Nadia's work was on. So with this, we can have like a user log in into their system and choose their theme and language, and then they can use the app on a different system, log in with the same account, and the theme and selection would be pre-selected for them, and also their history will show. And in the image to the right, it shows an example of what the input formula would look like for an account, and you'll see that in the application once we get to it. So next slide. So right here is the ER diagram. This is just basically the foundation of what the database is built off of. It's not a complex system. We want to make it simple, just kind of make it primarily on the user. So we just have user, language, theme, and query history as our tables. And yeah, next slide. And I'll pass it over to Ali.
Okay. Hi everyone, my name is Ali Altamimi, and I have been working on the local storage subsystem. So the three main data that we are storing locally are user interface description, settings, and user credentials. For the user interface description, we are storing all the labels in the application, whether it's in English or other languages. In case the user selected a language that is not installed, for example, French, then the application will generate a new local file for that language using the API that Nadia worked on. The reason why we are generating the files when selecting a new language is because the API takes like a minute or two to translate all the labels. So instead of calling the API every time the user runs the application, they can just run it once. For the settings, we are storing the changes in the user changes that the user selected in the settings view. Right now, the user can only change the language and the theme of the application. Lastly, the user credentials. In it we are storing user information so that the user does not have to log in the application every time they open the application. Yeah. And next, we have different themes to show. We have default, dark, tan, sepia, teal. I think that's how it's pronounced, teal. But it's also really easy to change the themes. So maybe we can add the features that the user can like change the theme for himself, like customize it. But yeah, now back to Joshua.
All right. So before we go into the demo, I'll just talk about the future work that we would like to do. So some of the algorithms that we used are very complex, as you may expect. So generating truth tables, for instance, the naive approach is actually NP complete because it is effectively the Boolean satisfiability problem. Theorem proving, that's co-NP complete. So we want to find approximations or maybe even deduce faster algorithms because at the moment we have an upper limit on how many atoms, how many distinct atoms, let me be clear, you can put in a well-formed formula. Because if you put too many, it'll basically take so long that the universe would explode before it finished. And also, first order predicate logic is already semi-decidable because of the universal quantifier and the identity symbol. So one thing that we wanted to say was, obviously, as I said before, practice makes perfect, but we added a feature to where users can generate their own propositional and first order predicate logic formulas. But the issue is that because there's no real good research on this topic, the algorithm that we implemented is very arbitrary at best and effectively undecidable at worst. So we'd like to do more research into that and hopefully improve its efficacy. And lastly, we'd also like to improve the error messages and the solution steps because the idea for this application was to help users like walk them through a problem. All right. So now we're going to, oh, oops, should not have done that. Okay. Now we're going to go into the demo. All right. So this is the main application. So when you first start it up, you can go and create an account if you want, where you can log in. Remember that when you log in or when you make an account, it saves your preferred language and your preferred theme. So instead of registering, we're actually just going to log into an account that's already there. Do that. And if you get the password or username wrong, it'll let you know. So this account, it had the tan theme and the Spanish language saved. So that's just demoing this. We're not going to continue in Spanish. But yeah, so let's log back out, and then we'll need to go through and actually reset it. All right, there we go. So now let's actually try an algorithm. So let's do a test for equivalence to see if two well-formed formulas are equivalent. So we'll do A implies B, and let's see, not A or B. That's the common equivalence that we all should know. So we hit solve, and then up here at the top, we can see that there are several algorithms to choose from. Depending on what formula you enter, that will determine which algorithms are available. So we'll go to general algorithms and then hit logically equivalent determiner and then hit apply. And as you can see, it will generate a result at the top, which says that these two are logically equivalent, as they should be. It will generate the truth table, or truth tree, excuse me. And as you can see, if you hover over it, there are derivation steps. So each line corresponds to a number, and the number beside of it in parentheses says which rule this was, or which step this piece was derived from, and what rule was used to get there. Okay, so there's also the parse tree for the formula, and there's the truth table, So we can't generate it for this, but we can if we put a negation on the outside. And now let's generate the truth table. So there we go. All right. So this relationship, this column, excuse me, proves that these two are equivalent. Okay. And another cool thing that we did was that if you are in a logic class that uses different symbols, you can just right click on them and then you can choose which notation you want to use. So for instance, the formal logic class at UNCG uses the ampersand instead of the upside down wedge. So we can just hit that, and then inside of the input box, we can just click it and it will use it as normal. So then we'll do truth tree generator, and it uses the notation that they prefer. And over here on the right, as was previously explained, it shows the symbol name, the formal name, alternative symbols, an explanation, and several examples of that symbol being used with different notations. All right, and last thing we'll show off is just the export feature, which is pretty cool in my opinion. So let's see if we can generate a good predicate logic formula. All right, that one looks fine. So we'll just do the same thing. We'll generate the truth tree for it. That looks fine. And then at the top here, you can go to export and then hit export as PDF or export as LaTeX. And then we'll obviously do the PDF. And you can save it as something, doesn't matter. I think it did it. Let's see, did that do it? Yep, that did it. So can you all see this window?
Yes, we see it.
Okay. Yeah, so this is the LaTeX version of that of this tree right here. So you can do this for parse trees, and you can do it for truth tables as well as truth trees, as we have shown. All right. So there are more features, but obviously due to time, we're not going to go into all of them. But that's pretty much it. All right. Does anyone have any questions?